Good morning, sir. Good morning to all of you. My name is Ajay Kumar. I am from Uttar Pradesh. I have done my post graduation from NIT Durgapur. So today we are going to discuss about first order reaction. So what is the first order reaction? What is the first order reaction? So this is the one of the most important topic from this chapter, chemical kinetics. So first of all, I will discuss what is the first order reaction. So the reaction in which rate of the reaction varies linearly with the concentration of reactant. Concentration of the reactant. So what do you mean by this? Let's say I have a balanced chemical reaction like this, in which A gives B. So this is the first order reaction. So this is the balanced chemical reaction in which stoichiometric coefficients are 1 and 1 respectively. Let us assume order of the reaction is equal to 1. Let us assume order of the reaction is equal to 1. If the rate constant of the reaction is equal to K, then I can write its rate law expression. So it is going to be rate of the reaction is equal to rate constant of the reaction and concentration of reactant to the power order of the reaction. Order of the reaction is equal to 1. जैसा कि हम लोग ने assume किया था, order of the reaction is equal to 1. At the same time, if I want to write rate in general expression form, it is going to be rate is equal to rate constant of the reaction and concentration of reactant to the power 1. This is the general expression for the rate law expression. So have a look on this equation through which we can define the order of the reaction. So first order of the reaction are the ones in which rate of the reaction varies linearly with the first power of the reactant. So any reaction in which the order of the reaction varies linearly with the concentration of reactant, we are calling this type of reaction called first order reaction. Now I am discuss few more things. I am going to plot few more curve. I am going to plot a curve between rate of the reaction and concentration of the reactant. This is y-axis and this is x-axis. If I am plotting along y-axis rate of the reaction and along x-axis I am going to plot concentration of reactant. Concentration of reactant. We know the nature of the curve y is equal to mx. So it is definitely going to be straight line passing through the origin. This is something like this. And what is the slope of this curve? Slope means value of m, and value of m is equal to k. So slope of this curve is equal to k. Value of m is equal to k, and is the slope of this curve. Okay. Now I am discuss about integrated rate equation for the first order reaction. Okay. Integrated rate equation for the first order reaction. First order reaction. So this is the simplest way through which we can define the first order reaction. So any reaction in which the rate of the reaction varies linearly with the concentration of reactant, we are called, this is the first order reaction, and this is the graph between rate of the reaction and concentration of reactant. Now I am discuss about integrated rate equation for the first order reaction. Let's say I have a balanced chemical reaction like this, in which A gives B. If the order of the reaction is equal to 1, order of the reaction is equal to 1, and rate constant of the reaction is equal to K. Let us assume, I will say at time t is equal to 0, I will assume concentration of reactant is equal to A naught, and concentration of product will be 0 at time t is equal to 0, because at time t is equal to 0 reaction will not be started at time t is equal to 0. Now at any time t, let us assume concentration of reactant is equal to AT, and concentration of product, let us assume, is equal to BT. Okay, you have to be careful with each terminology here. What is the A naught? A naught is the initial concentration of reactant at time t is equal to 0. And what is AT? AT is the concentration of reactant at any time t, and BT is the concentration of reactant. BT is the concentration of product at any time t. Let's say what is the rate expression for this equation? Rate is equal to rate constant of the reaction and concentration of reactant to the power order of the reaction, and order of the reaction is equal to 1. Okay. At the same time, if I want to write rate in instantaneous rate equation, it is going to be rate of the reaction is equal to minus d of A upon dt. This is the instantaneous rate equation. So this equation give me rate of the reaction, and this equation give me rate of the reaction. So from this equation and this equation we can write something like this: minus d of A upon dt is equal to K concentration of A. So I can simply arrange this equation. This is something like this: d of A upon concentration of A is equal to minus K dt. Just arrange this equation. Now Now I am going to calculate integrated rate equation for the first order equation. That means we need to integrate both sides. Now I am take integrated both sides. D of A upon dt, concentration of A is equal to minus K dt. On this side we have to integrate with respect to time, and time change from 0 to t. And this side I am integrate with respect to concentration of reactant, and concentration of reactant change A naught to AT. So we know the formula, integration of dx upon x is equal to ln x. So this is something like this, ln a at a naught is equal to minus, we know the also integration dx is equal to x. It is something like this. Now I am putting the integration value, ln at minus ln a naught is equal to minus kt. So consider this equation, we can write something like this, ln at upon a naught is equal to minus kt. So if I multiply in this equation with negative sign, so it will be like this, ln at upon at is equal to kt. So simply arrange this equation, k is equal to 1 by t ln a naught upon at. So this is what? This is the integration, integrated rate equation for the first order reaction. Integrated rate equation for the first order reaction. Now I am going to discuss few more equation for the first order reaction. There are 4 more equations which I can derive for you, so that you can draw any curve related to first order reaction. AT. If I consider this equation, this ln a naught upon at is equal to kt. If I convert this equation in form of log, so it will be like this, something like this, 2.303 log a naught upon at is equal to kt. So k is equal to 2.303 by t log a naught upon at. So this is the integrated rate equation for the first order reaction in form of log. If I consider this equation, we can write something like this. It is something like this, at upon a naught is equal to e to the power minus kt. So at is equal to a naught upon a naught into e to the power minus kt. So there are 3 more important formula. First one, this and this and this. You have to remember this